Good morning and welcome back. In previous lecture, we have discussed about supercharger or supercharging and different arrangements of the supercharging or different methods of supercharging. Now the next point is turbocharging or turbocharger. So we know the basic difference between supercharger and turbocharger. In supercharger, to run the compressor, engine output power is utilized. That means in case of supercharger, the engine output power is affected. But in case of turbocharging, to run the compressor, engine power is not utilized. The exhaust gas energy of the engine that is utilized to run the compressor. So in turbocharger, exhaust energy of engine is utilized to run a gas turbine, and the output of this gas turbine is used to drive the compressor directly coupled to it. See the diagram carefully. Output from this engine, that is exhaust energy during the exhaust stroke, that exhaust gas is expanded over the gas turbine. That gas turbine is directly coupled to the compressor. So due to this expansion of gas turbine, expansion of this exhaust gas turbine gets rotate, and that rotary motion of this gas turbine drive the compressor to suck the surrounding air and supply to the engine. So the turbochargers are extensively used nowadays for supercharging of all types of two-stroke and four-stroke engines. So this is nothing but what? Turbocharger. In turbocharger, exhaust gas energy of engine is expand over the gas turbine. Gas turbine produces some amount output work, that is rotary motion, and that rotary motion of gas turbine drive the compressor. Now the next is methods of turbocharging. Similarly, the methods of supercharging, some methods are there for the turbocharging. Now these methods totally depends upon the which form of energy of exhaust gas is utilized, because the exhaust gas have some amount pressure energy and some amount kinetic energy. So to run the gas turbine, which energy of the exhaust gas is utilized, so depend upon that. There are three types of or methods of turbocharging. So first one is constant pressure turbocharging. So as name indicates, constant pressure means in this method the exhaust gas pressure energy is utilized to run the gas turbine. See the diagram carefully. If there is a multi-cylinder engine, that is cylinder 1, 2, 3, 4. So exhaust of all these four engines is combined in a common passage or common pipeline, that is called as exhaust manifold. And from that exhaust manifold, that pressure energy of the gas or exhaust gas is supplied to the gas turbine. In the gas turbine, that exhaust gas get expand, turbine gets rotate, and that gas turbine is directly coupled to compressor. That compressor sucks the surrounding air and supply to the intake manifold of engine. So this is diagram. Now in this method, the exhaust of all the cylinders are released to a common exhaust manifold, from where it is supplied to run the gas turbine. It could be seen that the exhaust pressure of all the cylinder is constant and above the atmospheric pressure. The exhaust manifold is made big in size to absorb any pressure pulsations. So this system is very efficient in operation because the system is simple. Only we have to combine all the exhaust gases from each and every cylinder, and after that, by equalizing the pressure, that equal high pressure exhaust gas supplied to the gas turbine. So what are the advantages of this system? So in this system, the recovery of exhaust energy is efficient because we have to utilize the pressure energy. So recovery of the exhaust gas energy is efficient. Next advantage is the specific fuel consumption is low because we have to utilize the exhaust gas energy. So the specific fuel consumption is low. After that, the turbine efficiency is high because the high pressure and some amount heated gas, to that the turbine efficiency is high. Again, the exhaust piping is simple. The exhaust pipeline system is simple. There is no any complication. We have to directly combine all the exhaust gas into a single passage, that is called as exhaust manifold. Now the disadvantages of this constant pressure system is, for maintaining the constant pressure, it is necessary to use a large diameter exhaust pipe. Due to this, the pace and size increases. If you want to reduce the pressure pulses or pressure fluctuation, it is necessary to use a large diameter exhaust pipe. Due to this larger diameter, whatever the pulsation in pressure, that pulsation get reduces and constant pressure is maintained. So as you have, if you want to use a large diameter pipe, the size of the system increases. So this is one of the disadvantage of this system. Next one is a response to the change in load is poor. If there is a sudden change in load on the engine, the response from this system is low because there is some time is required to equalize the pressure. After that, that constant pressure gas supplied to turbine. So if the sudden load on the engine increases or decreases, in that case quick response is not given with the help of this system. Next, for efficient running, higher pressure ratios are necessary. If you want to run this system efficiently, high pressure ratio is necessary, and if pressure ratio is high, it makes the scavenging difficulty or scavenging problem. At the outlet of this exhaust valve or in exhaust manifold, if the pressure is mover, so it creates some problem for the scavenging process because complete scavenging is not possible as there is a high pressure inside the exhaust manifold. So these are the drawbacks or disadvantages of this constant pressure turbocharging method. So in constant pressure turbocharging system, the pressure energy, that is constant pressure energy of exhaust gas, is utilized. Now next method of turbocharging is pulse turbocharging, or it is also called as what? Bushy type turbocharger. So in this method, the kinetic energy of exhaust gas is utilized to run the gas turbine. So in previous system you have to utilize the pressure energy, but in this system kinetic energy of exhaust gas is utilized. Now see the diagram carefully. The diagram is somewhat similar to the constant pressure turbocharging, but only the exhaust system or exhaust pipe arrangement is different. So in this case, separately exhaust gas of each and every cylinder is directly supplied to the gas turbine without combining the gas or exhaust gas in a common passage. From each and every cylinder, the exhaust gas is directly supplied to the turbine. So the main objective of this system is to utilize the kinetic energy of blowdown gases to drive the gas turbine without much increase in exhaust pressure. To achieve the above aim, the exhaust lines are grouped together to receive the exhaust pulse as soon as the exhaust valve opens. Then these gases are gathered and passed from the narrow exhaust pipes directly to the gas turbine by the shortest route. If the route is short, then the losses are less. For that purpose, short route is used. After that, the separate exhaust pipes are used so that the exhaust process of various cylinders do not interfere with each other. The exhaust process of each and every cylinder is separate. There is no any interference between the exhaust processes of all the cylinders. So what are the advantages of this system? So the space requirement is less due to the short and small diameter pipes. In case of constant pressure, space requirement is more because of the large diameter exhaust tubes is necessary or used. But in case of space requirement is less due to the short and small diameter pipes. Next advantage, the recovery of exhaust blowdown energy is efficient because we have to utilize the kinetic energy, that is pulse energy of the exhaust gas. As soon as the exhaust gas comes out from the cylinder, whatever the kinetic energy, that energy is utilized to run the turbine. So the recovery of exhaust blowdown energy is efficient. After that, comparatively better scavenging is obtained at low load due to reduced pressure in exhaust pipes. In exhaust pipe, the pressure is low because the velocity is more. Due to that, scavenging is better as compared to the previous system, that is constant pressure turbocharger. So these are the advantages of this system. Now the disadvantages. So with high turbine pressure ratio, recovery of energy is poor because it requires the high pressure ratio at the outlet of the engine, that is exhaust manifold. It requires a low pressure, that is high kinetic energy. So there is a large pressure ratio is required. So recovery of energy in that case is poor. Next disadvantage, engine with larger number of cylinders require complicated exhaust pipe arrangement. So if the engine is multi-cylinder, that is number of cylinders are more. So from each and every cylinder, we have to give the connection, that is separate connection with the help of small diameter pipe, that is narrow pipes. So as the number of cylinders are more, there is a complication in this piping arrangement. After that, poor turbine efficiency is obtained because the pressure ratio is poor. So due to this, poor turbine efficiency is obtained. After that, scavenging process is disturbed if the waves are formed inside the cylinder. If the waves formation takes place, though difficulties arises for the scavenging process. So with the help of this pulse turbocharging, why the pulse name is given? Because in this method, the kinetic energy, that is pulse energy of exhaust gas, is utilized to run the turbine. Similarly, in previous system, pressure energy of exhaust gas is utilized to run the turbine, since it is called as constant pressure turbocharger. But for these two systems, some drawbacks are there. In constant pressure turbocharging, quick response is not given. In pulse turbocharging, pulse turbocharging system is complicated system, maintenance is more. So both these system have some advantages and some disadvantages. So if you eliminate the disadvantages of both these systems and only utilizes the advantages of this system, then again the performance or then again the COPO or again the efficiency of the cycle increases.